So in this video we're going to solve a classic work equals rate times time problem that involves two printers working together to complete a flyer order. So let's go ahead and read through the paragraph once. It says two printers working together can produce all of the flyers needed for a fundraising event in 2 hours, or all of the flyers needed for an order. So we have an order of flyers. And the two printers working together can complete that order in 2 hours. One printer, which is newer than the other, can produce flyers working alone in half the time it would take the slower printer. So we have one printer, because it can do the work in half the time, we have a printer that is twice as fast as the other printer. And then it says how long, so it's asking us a question about time. How long would it take for each printer working alone to complete the print job? So I want to go through and organize stuff a little bit. So they're going to work together. And they're going to work together to complete, they're going to print the flyers needed for the fundraising event. So the work that they're going to get done when they work together is to complete one order. We don't need to know how many flyers are in that order. We just know that they can complete the entire order in a 2-hour time period. So now we know time. We know time that it takes them is going to be 2 hours. And then there's going to be a rate at which they are able to work together. And we know that the work they get done equals the rate at which they work together times time. And the work is actually one order. So what we know is that one order is going to equal the rate at which they work together times time. Now we're given some information about the individual printers. So we have a fast printer. And the fast printer, it has a rate. I'm going to call it rate of the fast printer, rate sub F. And we've got a slow printer. And we're going to call that rate sub S for rate of the slow printer. And we know that the rate of the fast printer is, because it can get the work done in half the time, we know that the rate of the fast printer is double the rate of the slow printer. We know that the work they get done equals their rate times time, and the rate that they work together, we know from the previous video that the rate at which you get work done when you work together, if you assume constant rate, is just equal to the sum of the rates. But the rate of the fast printer can be written in terms of the rate of the slow printer as twice the rate of the slow printer. So we can replace this with double the rate of the slow, which is nice because it reduces the number of variables. So the rate at which they work together is just going to equal 2r sub s plus 1r sub s is 3r sub s. Notice now that this is the rate at which they work together. So I can come over here and say, hey, this one print job that they can do together in 2 hours, I can replace the rate together with 3 times the rate of the slow times time. 3 times 2 is 6 times the rate of the slow equals 1, and divide both sides by 6. I get the rate of the slow computer is 1/6. And what we want to remember is what the rates are. So rate in this case represents how many orders you can complete per hour, right? So in this case, this 1/6, what we want to recognize is the 1/6 has units. This says I can do one order because the rate is orders per hour, so one order in 6 hours. So we already, that just knowing the rate tells us how long it would take the slow printer to complete the job. The time it would take the slow printer to complete the job would be 6 hours. We can extract that directly from the rate of the slow. The other way we could do it is we could say, hey, we know that work equals rate times time, and we're being asked how long it would take for the slow printer to do the job or complete the order. So for the slow printer, it would still be work equals rate of the slow times time, but the work that needs to get done is one order. So we could set up a formula. We could say work equals rate of the slow times time. We don't know what time is because we're being asked to find how long would it take the individual printers to do the job, but we know that the work is still one order, and now we know the rate is 1/6 order per hour times time, and if we multiply both sides by 6, we get 6 hours equals time. It would take the slow printer 6 hours, and if the faster printer can get the work done in half the time, it will only take the faster printer 3 hours. So fast printer can do the job in 3 hours. Slow printer takes 6 hours. Again, I don't need to set this formula up if I think carefully about what the rate means, one order per 6 hours, and I want the rate of the slow is telling me how long it takes to get the order done. We could calculate the rate of the fast. So up here I have the rate of the fast is equal to 2 times the rate of the slow. The rate of the slow, we know it's 1/6. And 2 times 1/6 is 1/3. So the rate of the fast, if we look at it this way, is 1/3, or because rate has orders per hour as its units, this is 1 order per 3 hours. 1 order per 3 hours. So it would take that printer 3 hours to do the job. So there's another way that we could look at this that maybe gets things done a little bit more efficiently. It would still require that we think about what's going on when they work together. So the work that they get done when they work together is one order. The time that it takes them when they work together is 2 hours. And from this, the rate that they are working together, we can actually get that straight from this. They were told they get all of the flyers done in 2 hours, so their rate is 1 order per 2 hours. That's how fast they work together, 1 order per 2 hours. And then I could look at the fast printer, and I could say, look, the work that needs to get done is 1 order, and the time that it takes the fast printer to get the work done, well, I don't know. So I just represent it with the time that it takes the fast printer to get the work done. But if I do that, then the rate of the fast printer is 1 order per the time it takes the fast printer to get the work done. 1 order per T sub F hours. And the slow printer, we can look at him. The work that we want done is 1 order. And the time that it takes the slow printer to get 1 order done, we don't know that. But if we represent that rate with T sub S, then we're going to see that the rate of the slow printer is going to equal 1 order per T sub S hours. The rub here is that we know that the fast printer can do the job in half the time that it takes the slow printer. So we also know that the slow printer is going to take twice as long as the fast printer. So if we've represented the time it takes the fast printer to get the job done 1 order as T sub F, then time it takes the slow will be double the time it takes the fast printer. So I can also write the rate this way. I can say you're going to equal 1 order in twice the hours that it takes the fast printer to do it. And then if we use the relationship that the rate working together equals the sum of the rates, we can get an equation out of this, because the rate together is 1 order per 2 hours, which equals 1 order over T sub F plus 1 order over T sub S. That's the rate of the slow, but this would introduce 2 variables. We'd like a single variable, but I can replace 1 order in T sub S hours with 1 order in twice T sub F hours, because the slow printer takes twice the time that the fast printer does. And then when I look at this, I just have a rational equation like we did in homework 15, I think it was. And I can look at this and say, hey, if I multiply everything times 2t sub f times 2t sub f, stuff's going to cancel. I'll get 2 divided by 2 is 1. And 1 times t sub f times 1 is just t sub f equals, this can distribute into the parentheses, so I get 1 over t sub f times 2t sub f plus 1 over 2t sub f times 2t sub f, and some stuff's going to cancel. T sub f divided by t sub f equals 1, so I get 1 times 2 times 1 is 2. The time it takes the fast printer equals 2 plus 2t sub f divided by 2t sub f equals 1. 1 times 1 is 1. The time it takes the fast printer is 2 plus 1 is 3 hours. So now I know how long it takes the fast printer to get the job done, but I know that the slow printer is twice that, so the time it takes the slow printer is 2 times the time it takes the fast printer is 6 hours. So same answer that we got on the previous slide, but kind of taking a different approach to solving it.